Hi there, this is Ms McTaggart. In this video we're going to look at some National 5 straight line exam questions. Now these are questions that go a wee bit out with the normal kind of ones we teach in class. They're more problem solving and they're definitely a bit trickier and more likely to catch out in the exam. So I maybe teach these all together as one wee roundup lesson, and it's generally these are the kind of wee questions that are for like the A candidate pupils. So let's have a look. I'm just going to work through loads of like exam past paper questions of these. So my first question here is we've defined the equation of the line for part A, which is nice and straightforward. Hopefully we're going to use the straight line formula, but it's the part B that's a wee bit different in this one. So part A, we should already know how to get the gradient of a straight line by doing subtract your y's over subtract your x's. So if I do 7 minus 1 all over 1 take away negative 2, so that becomes a 1 plus 2. So my gradient is 6 over 3, which is 2. And then I'm going to plug this into the equation, y minus b equals m bracket x minus a. I'm going to use this 1, 7 as my a and b to plug in. So I'll have y minus 7 equals 2 bracket x minus 1. And if I expand this out and move everything over, so I get 2x minus 2, that minus 7 gets added on, so minus 2 plus 7 gives me plus 5. So here is my equation of the line. This is what we wanted for part A, my equation of the line. Okay, now we're going to look at part B. The line also passes through the point A, 3A, find the value of A. Now, in maths, one of the most important things we can teach you is that whenever we give you a coordinate, we can label any coordinate x, y. And if you don't know what to do, have a bash subbing that in. We know x is a value of A and y is a value of 3A, so I'm going to put that into my equation. So y gets replaced with 3A. The 2x in the equation becomes 2 times A, because I'm replacing x with A, and then I've got plus 5. Now if I then subtract 2A from each side, I am left with A equals 5. And in fact, this coordinate here would have been 5, 15. That's what we would have had for that one. And if I just want to double check this again, if I replace x with the number 5, I would have 2 times 5 plus 5. That would give me y equaled 15. So the answer to the question is A equals 5. This one has come up twice actually, and there's two similar ones to this in the video. Find an expression for the gradient of the line joining these 2 points together, and straight off people look at it and go, oh, there's letters in that coordinate, don't like it. Just apply your knowledge from previous. They're talking about a gradient of a line. So we're going to do x1, y1, x2, y2 as normal. And then I'm going to do my gradient formula, so subtract the y's. So I've got 4p squared minus 9 on the top. Subtract the x's, I've got 4p minus 6. Now, if nothing else, just for plugging into the gradient formula, you've got a first mark. Remember, it's all about picking up marks where you can. This is your clue for the next bit. In its simplest form, if you stare really hard at these two lines, it's a fraction. They're asking you to simplify it. Now, if you have not been taught factorising and simplifying algebraic fractions yet, you won't know how to do this. However, you should have seen common factor and difference to two squares by now. This top line is a difference of two squares. So to get the 4p squared, that comes from 2p times 2p. And to get the 9, that comes from 3 and 3. 1 a plus, 1 a minus, doesn't matter which way round it goes. Bottom line has a common factor of 2, so divide both things by 2. I forgot to divide by 2 there. So that leaves you with 2p minus 3. Oh, there's the 2p minus 3's can cancel out. And that leaves you with an answer of 2p plus 3 all over 2 for your final answer. So for that one, we've seen coordinates, they're talking about gradient. Just do what you would normally do. And then that last bit might not come to you, but it might if you're good at your factorising. Here's another one. A straight line has the equation 4x plus 3y equals 12. Straight away, I don't like the layout that's in because we're used to it being in the form y equals mx plus c. 2 parts to it. Find the gradient of the line. So part A, I'm going to rearrange it, change the subject to y. Part B is asking for the coordinates of the point where this crosses the x-axis. Now we get that used to that same y-axis that this would catch a lot of people out that year. So first thing I'm going to do is rearrange this equation here to be y equals. So I'm going to move the 4x over. So I've got 3y equals negative 4x plus 12. And then I'm going to divide everything by 3. And that doesn't divide by 3, so I'm leaving it as 4/3. 12 divided by 3 is 4. So the gradient of this line is the value in front of the x. So the gradient equals minus 4/3. And I always write gradient equals. I don't like writing m equals. I want to make sure I answer the question properly and say the gradient is minus 4/3. If they ask me for the y-intercept, which they haven't, the y-intercept would be 0, 4. Now this question doesn't ask in part B for the y-intercept, but sometimes it does, so just watch the wording. This one asks where it crosses the x-axis. So where it crosses here. This is what we're after. Now, this is a bit trickier because you don't just read that off from the equation like you do the y-intercept. I need you to remember that anything on that x-axis is along something, and then it's because it's on the x-axis, it's up nothing. So here is your clue here. Y is 0. So if I replace y with 0 in my equation, I'll be able to work out what x is. Now I've got the choice. I can use my rearranged equation, or I can use the one at the beginning. The one at the beginning is going to be easier because if I replace that 3y with 0, that's just going to be 3 times 0, which is 0. So I'm just going to write this in. So I've got 4x plus 0 equals 12. So 4x is 12. So x is 3. Now just watch the question said find the coordinate of the point. So as a coordinate, that would be 3, 0. Now that's been asked a couple of times to find where it cuts the x-axis. So just to put that in there, because it's not something we generally always teach because it is a wee sneaky question. Okay, I like this one. This is a multiple choice one. So we've got 4 pictures of straight lines and we have to say which one could be this equation, 2x plus y equals 3. And we have to give 2 reasons why it is that one. So we could do a whole process of elimination really for this one. First thing is I'm going to rearrange that equation. I'm going to take the 2x over. So that gives me negative 2x plus 3. So because it's negative 2x, that means I have got a negative gradient. So I've got a negative gradient. So negative gradient means I am looking for a downward sloping line. So straight away I can eliminate the 2 upward sloping lines. It is not those 2. So it's one of these 2, B or D, because it's a downward sloping line. Now the plus 3 is my y-intercept. So it's got a positive y-intercept. So I'm looking for the one that cuts the y-axis in a positive place. Well, this one's in a negative place, so it's not that one. So the answer is D. And my 2 reasons would be because I'm looking for the one that's got a negative gradient and a positive y-intercept. D is the only one that suits that. That's a really good question to test your knowledge of what we're actually doing here when we're finding the equation of a straight line and what does a straight line actually look like. This is another kind of strange one. It's a wee bit different to the norm. They've given you the equation of a line in a jumbled up form again. And they've asked for the coordinates of A. So this is asking you for the y-intercept. So there's 2 ways to do this. We can rearrange it as normal and read off the y-intercept, which I'm going to do, and then I'm going to show you the other way. So if we rearrange it, we end up with 3y equals negative 4x plus 36. If I divide everything by 3, I get minus 4/3 x plus 36 divided by 3 is 12. So the y-intercept coordinate A is 0, 12. But there was another way. If you think to what I did in a previous example, well, I knew that coordinate was 0 something. So if I just replace x with 12 in this original equation up here, so this one here, if I replace x with 12 in there, if I replace x with 0 in there, I get 0 plus 3y equals 36. Well, 3y is 36, so y is 12. So you can get it from there as well. Either way, the answer is 0, 12 for coordinate A. Part B then says the line meets the line, another line here, through B at 0, 8, which is parallel to the x-axis. So basically we've got another line parallel to x-axis that cuts my line in part A, and we have to find the coordinates of C. Now parallel means they're running at the same angle, the same distance like train tracks, so they have the same gradient. So the x-axis and this line here, which I'm just going to draw over in green, have the same gradient. They both have a gradient of 0 basically. So I have to find the coordinates of C. Now I already know part of the coordinate C. I know it is along something and it is up 8 because it's the same distance up as the coordinate B. So I know I want to find out the x coordinate. I already know my y coordinate is 8. So I'm going to replace my y coordinate with the number 8. Now easiest place to do that is into the first equation again because it's not got fractions. So I'm going to replace x with the number 8. So I've got 4x plus 3 times 8 is 24 equals 36. I'm going to take away 24, which leaves me 12, and 4 into 12 leaves me with 3. So actually this coordinate of C was along 3 up 8. So you're seeing a lot of these questions that I'm showing you are all about plugging in a value for x or y, plugging in a coordinate. Okay, here's another one, very similar to one of the first ones I showed you where it became difference of two squares. We have to find the gradient again in simplest form. So I'm going to do the gradient formula. I'm going to subtract my y's. So I'm going to have t minus a all over t squared minus a squared. Now, because I've already done one like this is actually an easier one. I can't do it to the top, but I should hopefully spot that that bottom line is a difference of two squares. So it's 2 minus t minus a, t plus a. I can then cancel out the t minus a's, which leaves me with a t plus a on the bottom. But what does it leave you with on the top? A lot of people in the exam would write t plus a, but that's on the bottom. Remember, if you think there's something missing on the top, there's secretly a number 1 in front of this. There's a common factor of 1 running through the t minus a. So it's 1 all over t plus a, and that's perfectly acceptable with or without the brackets there. So they've used that question twice, so it's very likely they might use that again. Okay, this one is just another one about playing about with coordinates. We've got the line with equation 1/3 x plus 2 shown in the picture. We have to find the coordinates of B. So let's think again. Right, well, B is on the x-axis, so we already know that B is along something up 0. So I know that my y coordinate is 0, so I'm going to replace y with 0. So I've got 0 equals 1/3 x plus 2. I'm going to take the 2 to the other side, so that becomes negative 2. Equals 1/3 x. Now to counteract the third, I'm going to multiply by 3 because that would just make it 1. Or you might think of cross multiplying by 3. So minus 2 times 3 gives me minus 6 equals x. And that matches the picture. B is clearly a negative coordinate. So B is the coordinate negative 6, 0. So yet again, it's about testing what you know about your coordinates on the x and y axis. Now part B for this one, it says for what values of x is y less than 0. So basically asking you for this bit down here. When is your straight line below the x-axis? So anything before the number minus 6 there would have given you a negative value. So for what values of x is y less than 0? Well, it's whenever x is less than minus 6. So anything less than minus 6 will have that graph below the x-axis. Okay, this is my last one. This has come up, I've seen about 3 different variations of this same question. It's given you something that looks a bit like equation for straight lines. Sometimes they change the letters around. And then they ask you to draw a sketch of possible graph. So it's testing your knowledge of straight lines again. So it's told us that A and B are both less than 0. So if you look up here, y equals ax plus b. Well, if A is less than 0, then that means we've got a negative gradient, so we've got a downward sloping line. If B is less than 0, it means we've got a negative y-intercept. So I need to draw a downward sloping line. I'm going to put in my y-axis. Now I said that I had to have a negative y-intercept, so my x-axis is going to go about there. So there I've got a downward sloping line with a negative y-intercept. Now the only thing to do here to guarantee full marks is I need to mark on that that y-intercept is B. And that was a little niggly bit in that question. Whenever it's been asked, if that's not labelled as your B value, you won't get full marks. So watch out for that one. It has come up quite a bit and it always catches people out. It's worth 2 marks at the end of the day, but for some people it's a really easy 2 marks if you fully understand the straight line. So thanks for watching. I hope this has helped, letting you see and experience some really tricky straight line questions. Really good preparation before an exam in case something similar comes up. Thank you. Bye bye.